All right, hello people who are gone at the blood drive and anyone else. This is the John Baylor test prep. This is our final project before we do chapter 9 review, and it is comparing two samples. That's what we've been doing this whole chapter, is comparing two samples. This one is going to be based off of mean. So 9-3 stuff, population mean. All right, listed below the ACT test results from 12 Blue Hill students. This is legit data from I don't know, 5 years ago. This was the last year before COVID. Okay, I gathered up ACT scores. Of course, I did not put names to these, but you can see the date that they took them. I did have access to that information. This was pre-COVID or John Baylor test prep, and then they went through the John Baylor thing, and then these were their scores afterwards. So let's just compare this first person, right? Their composite score was a 14 on the ACT. Pre-John Baylor, they raised it a point to a 15. The next person was a 25. They went to a 26. 28 stayed the same. Okay, we had another 25 going to a 26. Then we had somebody that jumped a little bit, quite a bit, 15 to a 19, right? You see how this is playing out? But not only do I have the composite scores, which is the overall total scores, but I have math, science, English, reading, okay? That is for 12 students. Now, there were more than 12 students in the class that year, but there were only 12 that did take the ACT prior to John Baylor. Does that make sense? Because the rest of the students only took it on the one day that they took it as a junior, right? So that's why I don't have more than 12 students, okay? So we have this information. There is all that stuff. I have the mean, standard deviation. So the composite score for pre-John Baylor was a 22, 22.1 almost. And then it went up to a 23.5 for an average score, right? For an average composite. Does that make sense? Okay. This is legit Blue Hill data. I'm not making this stuff up. This is actually what happened, okay? All right, so compute the differences between the two tables of scores above and fill in the following table. All right, so what we're going to do is we need to find the differences, which means we're going to subtract. We're going to do this part together, okay? We need to subtract some stuff. Now we got to decide which direction we're going to subtract. So are we doing these ones minus this one, or the second one minus the first one? Which one would be the better one to do? Why the second one minus the first one?
Because the second one's bigger.
We're thinking that the second scores are probably higher than the first scores, right? So we're doing all the twos. We're doing the mu. Let's do x bar 2 minus x bar 1, all the averages subtracting, right? We're doing the twos minus the ones. All right, so you got to help me out here, and let's subtract. So let's do all of the composites all the way down. We got 15 minus 14. So in this first spot should be a 1. Do you see how that works? Yeah? Okay. All right, 26 minus 25, that is 1. 28 minus 28 is 0. Do you see how I'm doing this? Okay. All right, why don't we go through and you guys help me with this table, and you do some of them, and then we'll compare, okay? Can we do that? So fill in the composite. How about, let's say, Maya and Jake, let's have you do the math.
The what? Oh.
The math column. Can you do the math column? The second one minus the first one?
Yeah.
Okay, Clayton and Rachel, do you want in on this?
Are you talking to me?
Sure.
Gracie and I'll do English. I'll start from the bottom, you start from the top.
I don't know what I'm doing.
Gracie and Emma do English. Okay. Rach, let's just have you three do science. And then Craig, do reading. And I'll check yours.
How am I doing?
Okay. There you go.
I
Oh,
have
you have this. Okay, Craig, do reading. Go. The second one minus the first one. Fill them in.
You need this. I can't read.
Which one?
Yes,
It's
I'll
a
take it.
tiny stony.
0.
You're subtracting the first time I took it versus the second time.
4, 2, 1, 3.
Trying to figure.
3, 0, 0, 2, 2.
What's that?
These are some awful ACT scores.
Hmm?
A 14, a 10.
Yeah, have you taken it yet?
Yeah, I got a 23.
Which
You
one?
got a
are
23
at?
on your ACT? Nice.
I have 5 done.
4. Am I getting any negatives yet?
Yeah, I have.
Oh, okay.
I'm getting a lot of negatives for reading.
Reading sucks.
2.
So it goes 1. 1.
Then we got a 5. like 5 is a difference. I mean,
Is the right after?
5 to 8.
the right one's after.
Alright. So negatives get put on here too?
4 to
Yes.
3.
I'm literally so bad at math, Coney. Don't look at my answers.
I must make done.
All right, somebody do the composite and the reading to make sure that I'm correct. Okay, I'm gonna do the
doing
math
reading.
one now.
I'm doing reading.
Okay, 1 and minus 1 and 1 and 2 and 1 and 6. I can't add. And 4, 3, 1.
Ah, shoot, I was getting this wrong. Maybe, I don't know if I really was.
No, that is not right. That's supposed to be a 0.
Negative 4.
No, it's not. No, it's not. Negative 1, 1. Nope, no, not in the right spot. This should be a 3, 4, 6.
How much do you want us to round, like, the standard deviation and the means?
I think we did like 3 decimal places before.
Okay.
6. This is 1. I'm so messed up on my numbers. There we go.
Why are the scores going negative?
Because they
2.
went
There we go. Okay, anybody did anybody do math?
Yeah, I know.
Yeah.
Are you checking the math?
Yeah, math is right.
Math is right? Because I just got done with the math column. Science. I gotta circle them, so otherwise I can't see. There we go. Minus 1. Minus 1. 5. 0, 5.
I finished reading. Oh, you already did that.
Check it to make sure.
4, negative 1, negative 4, 2. What's that number? 1. Negative 1, that's what it is. 5.
Who had science?
I did.
That's right.
Yeah, negative 1.
Good on science? Alright,
1,
I got English left.
5.
Who are my English people?
Gracie and I got it, double checked
You got
them
it?
and everything.
1.
1.
And holy crap, 9.
9.
Woo! Negative 3. 2.
8.
8. Jeez, English is crazy. 8. Okay, hold on. 2, 5, 6. Right? Then 1, 5, 9 again. Jeez. And 1. Is that true?
Mhm.
Yeah, perfect. Okay, so there's my table of my differences. We're subtracting. Second one minus the first one. So after John Baylor, before John Baylor. More positive numbers or more negative numbers?
More positive.
More positive numbers.
Except for reading.
Except for in reading. Reading was, I don't know.
No one.
Reading. Do you think John Baylor helped you with reading?
No.
Okay, we're going to decide if these changes were significant enough to say that John Baylor was effective in each one of these areas, all right? So when we calculate the mean, which is the average difference, we're doing the average difference. So like mean, these would be like your D bars because it's the difference, right? The average of the differences. And then you have your standard deviation, which is S, okay? All right, so for composite, if you add those all up and divide by 12, does anybody got those numbers? We're starting to get those numbers. Does anybody have a calculator that I can get those numbers?
My phone.
Pass it on over.
You're gonna get that before Coney, I'm sorry.
Oh, okay. Sure. 7,
I got 1.4.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 divided by
What did you get?
12.
1.42.
Okay. 1.417. Is that what you just said, Sarah?
Yeah, I just
Ah,
rounded it.
okay. All right. 3, 4, 5, 11, 15, 16, 17, 18, 19 over 12. 1.583 is what I got. Somebody be checking these. 10, 11, 17, 21. Actually, let's go back to 17, 20. 1.667. English, 7, 8, 9, 17, 18, 19, 24, 30, 31, 36, 46. Holy bejeez. Jeez. On average, English was raised almost 4 points apiece. That is insane. Cancels. 1. Cancels. Back to 0. -2, -3, -8, -11, -12, and -8.
Oh, that's an 8.
8 divided by 12 is negative 0.667. Just
Where
like
are those papers at?
John Baylor? I don't know, somewhere right.
Somebody made me throw my calculator at her, so all the papers.
Okay, there's my means. I should have put these on a spreadsheet because now we have to do standard deviation. So we have a graphing calculator.
There's one
Mallory
here.
does.
Ah, Mallory, hand it to me. I should have put these numbers in already. True.
Was that necessary?
Okay.
Why is
One,
everybody
one.
looking at me?
That was
Zero,
loud as
one,
that.
4, 2, 1, 3, 0, 0,
That coffee
2, 2.
pissing me off.
Stat.
Is it nice out?
Go. Okay, standard deviation. 1.4, yep, that's true. 1.240. There's that one. Okay, write that down. Here we go. Clear. We got 1 and -1. And 1 and 2 and 1 and 1 and 6 and 4 and 3 and 1 and -1 and 1. And average is right. 1.975 is the standard deviation. Okay. We've got -1, -1, 5, 0, 5, 1, 0, 6, 4, -2, -2, and 3. Average is, my average is not right. Did anybody get a different average or did you get 1.67? Let me do that one. Okay, -1, -1, 505, 106, 4, -2, -2. No, mine's wrong. Oh, and 3. Okay. All right, change that average. 1.5 is what it should be, I think. Exactly.
Do you have whiteout?
I don't know for sure. 2.939 is the standard deviation. Stat, edit. Clear, I got 2 of these left. All right, 1, 9, -3, 2, 8, 2, 5, 6, 1, 5, 9, 1. All right, average is right, 3.762 for a standard deviation. Last one. 4, negative 1, negative 4, 2, negative 1, 5, negative 7, negative 1, negative 5, negative 3, negative 1, and 4. And that is
Sarah's dead.
I'm literally choking on air right now.
One time I choked on water in the middle of Ninja.
okay. 3.798.
Gracie and I almost knocked the table down.
There you go. There's your standard deviation. Okay, get all those down.
Where?
Mean, standard deviation. All right, got it? Good? Ready to go?
No.
Okay, so what we're going to be doing is we are going to be doing every one of the 4 categories plus the composite. I'm going to do the composite with you. That is here at the bottom. Okay, we're going to do our hypothesis testing and everything, and then answer this question. Does John Baylor appear to be effective for composite scores? Then on the back side, you're going to do each one of these for math, science, English, reading. Got it?
No.
Okay? All right, and it's going to be exactly the same as composite scores. All right? So what we're doing down here, you're going to do 4 times on the back, but it should go a lot faster because you already have everything ready to go. I'll set you up for that, okay? We are also going to look at whether a significance level, these are all your fish values, to see whether it makes a difference or whether it changes the outcome if we change the fish value. Make sense? Okay, so we're going to look at that as well. I know you had one question like on a homework assignment at one point that says, does it make a difference if we change it from 0.01 to 0.05 or whatever, okay? All right, so use the differences above to test the claim that the average composite scores for the test prep is the same as the average composite score after John Baylor, right? So we're doing averages. What variable do we use for average? Yeah, so like we would say like mu1 equals mu2, but that's like saying that mu d is equal to 0, right? Like the difference between them is none. Got it? So rather than writing it like this, they have us write it like mu d equals 0, okay? Then we don't know whether John Baylor is being effective or not. We can guess according to our table, but they just say, is there a difference? So we're gonna say equal to, not equal to, okay? All right, got it? Good. We're gonna claim, let's see, claiming that it is the same, okay? So which one does our claim go with? H9, yep, claim goes here. Okay, so we're going to answer that question and then we're going to see whether it's effective or not, okay? Okay, all right, here we go. Let's do this. Two-tailed or one-tailed? 2. Left and right. All right, so which table are you looking at for this?
Oh,
For like the critical numbers? The T chart, right? Okay. All right, on the T chart, we need the percentage, which is going to change, and we need the degrees of freedom. How many degrees of freedom is it? 11. We have 10 or 12 students, so 11 degrees of freedom. All right, so for this first one, let's just figure out what all our numbers are down here, right? For the first one, if we have a 20% fish value, that means 10% goes in each one, correct? Okay, which means we're looking at 80% on the T chart at 11 degrees of freedom. 1.363 and negative 1.363. Those are our cutoff marks, right here and right here. Does that make sense? Okay. So 1.363, negative 1.363. All right, if we switch that to 10%, that means 5 goes in each one, or 90% in the middle. What's 90% at 11 degrees of freedom? 1.796 and negative 1.796. Okay. 5% means 2.5% goes in each one, which means 95% at 11 degrees of freedom. 2.201 and negative 2.201. And then the last one is 1%, which means 0.5% goes here and 0.5% goes here, which means 99% in the middle. And 99% at 11 degrees of freedom? 3.106. Thank you so much, Sarah.
Yeah.
Perfect. Yes. Okay, so those are the numbers we're looking at, right? We're going to compare. Okay, test statistic. We have a formula for our test value, and it is that like T equals, I don't remember what it was, like D bar minus mu D, is that what it is? Over SD over the square root of N. Check that and make sure. This is from 9.3.
It is T equals D bar minus ND over SD over the square root of N.
Yes, okay. All right, so there's our test value. Now, here's the deal. What is mu D? 0. We're assuming that the difference is 0. So really, it's just D bar over that stuff, right? All right, so when we're doing this, D bar for composite. What was D bar for composite?
1.417.
Yep, 1.417. It's this number right here. Over the standard deviation 1.240 divided by the square root of 12. That's going to be the only calculation I have to do for this one. Okay? All right, a couple people do that, and let's see what we get. What is the difference? Or what is our thing? What is our number? You might get a big one. 3.96. Okay, that is the value for our test value. Okay, so we're saying the average composite score is a 3.96. So at the first fish value, he lives all the way over here, which means not equal to. So I'm going to cross this one off and I'm going to say that they're not equal to. Is it in that same spot for all the fish values?
Yes.
Yes, it's getting closer to being okay with this one, but it's still far above. What does that mean? We're saying the differences are not 0. We're saying there is a difference between before and after. So does John Baylor test prep appear to be effective on composite scores?
Yes.
Yes, according to this, there is a difference. The difference is not 0. There is a difference. So yes, effective for composite scores. Okay, John Baylor did in fact happen to raise the average enough to say that something was happening, right? It wasn't just a coincidence that it was above. It was high enough above average to say, yep, there is something that's affecting that. Does that make sense? Okay, so on the back side, I give you one bell curve at the top because you really don't need a whole lot of bell curves. They're all going to be the same. Your H naught is still going to be that the difference is going to be 0 and the difference is not equal to 0, right? You still have 2 tails for your fish value, and then our fish values are there. We could just copy those numbers from the front side, shall we? They're going to be the same. 1.363, 1.796. I'll zoom in here in a second as soon as I get them up here. And 3.106. Negative, negative, negative. All right, so positive 1.363. 1.796. That's the cutoff mark where each one of these bell curvy things is. Do you understand what I'm getting at here?
Yeah.
Okay, there's my stuff. All right, so all you need to do for homework is to go through and calculate the test value for each one and then say whether you're going to reject or fail to reject. And then does that mean it's effective or not effective? Now, in some of them, it will be effective for all fish values. In some of it will be effective for 2 fish values, but not the other 2 fish values, right? Okay. Some of them it won't be effective at all, right? Like the reading scores, we kind of guessed that maybe reading was not effective at all, right? Because the scores actually went down after John Baylor for reading. Okay, so that's what you have to decide. You have to fill these in. You can just circle which one it is, right? Like reject or fail to reject, whatever. I don't know how you're going to fill those in. But anyway, okay, calculate your test values. If you need the formula, here it is again. T equals D bar minus mu D. But mu D is 0, so you really don't have to do that. Over standard deviation over the square root of n. Calculate those from the front side numbers. Put your test value here, and then circle whether it seems to be effective or not effective. We'll go over these results tomorrow, okay? Not terribly difficult. Questions before I stop? We're just doing averages. Use. Okay, there you go.